So now for how this works. The bow and drill is probably the optimal way to perform a friction fire. A friction fire is just how it sounds. The friction produces the heat that causes the fire. The bow and drill is the optimal way of primitive fire making, of making fire out of nothing but what you can find in the wild, because it relies the least on physical strength and the most on mechanical amplification of force, as well as body positioning and body weight to generate the force and the friction needed for the heat. So what we have going on here is a very straight, lightweight, hard drill penetrating a soft, lightweight wood, okay, drilling through it. Now as this drills through the softer wood, it's going to create dust, just like it would with a mechanical drill. Now that dust gets trapped in the notch here. Now once that notch is full and that dust is trapped against this red hot spinning drill, as long as there's enough oxygen, that dust is going to ignite. Okay, once that dust is lit, it's transferred to the tinder bundle, and then you encourage it, and by encourage I mean blowing and blowing into open flame. Now for the posture. The posture is critical to this. You want your body weight and body mechanics doing all the work for you. You don't want to struggle. First we put the drill on the string. Now, I want my foot well onto this board. I want the ball of my foot just past the edge of this board. That means there's a lot of weight on this board, so it's not going to swivel. Now, once you start bowing and drilling, you're not going to have an ember until your notch is full. Once your notch is full, the dust will get trapped against the drill and potentially ignite. So if the board swivels back and forth, you can have your dust, which is going to form your ember, fall out. And that's another thing. If you lift your drill out to check and see if you have a coal, never disturb your dust in there until you're sure you have an ember. Never remove it from the notch, because it's not going to ignite until it's full, so you don't want to have to do all the effort again. Now I have my foot, it almost looks like, if you saw in the demo, like the string was hitting my boot. It dang near hits my boot. That's because I want my wrist right on my shin, and if my foot is close to this drill, it puts my wrist on my shin, okay? Now leaning forward with my wrist against my shin keeps it locked in place so that I don't have the wobbling, okay? And I don't lose my downward force, and I don't have this flip out, okay? Now my knee should be directly behind, just about directly behind my heel. That's because I need a full stroke here. I want my stroke to be forward and backward. I want it even and level, okay? I don't want arcing. An arcing motion can have my drill pop out of the baseboard, and that's no good. I want it straight forward and backward, as if the tip of my bow is a sword and I'm stabbing at a target. You see, straight and level. So now let's talk a little bit about selecting the materials. First off, get what species all this is out of your head. We're going to go over that later. But what's important is understanding why these things work, so that you can identify species in the field when you're not familiar with local plant species. First, you're going to select a drill 7 to 10 inches long and of a freshly dead specimen. You'll know it's freshly dead because the bark will still be intact and of good quality. Now this species of wood has a fairly smooth bark here, and some species of wood will have a real rough bark that you'll have to carve off. If it has a smooth bark, leave it on, because that helps the drill, that helps the string travel around the drill. Now it should be at least 7 to 10 inches long. This one's got a little bit worn down, but you want it at least from fingertip to palm, really even an inch or two more. Okay, it should be about the width of your forefinger. It can be a little smaller, that's no problem. It could be a little bigger, but it shouldn't really be as big as your thumb. It should be smaller than your thumb. Okay, now the reason we want it 7 to 10 inches is for the posture. Okay, I want my heart right above the drill. Now if I'm down here, my body weight's all on my back foot. If my drill is too tall, you see, it'll bring my body weight back here. Okay, if my drill is too short, I'll be leaning too forward, I'll be off balance, and my body weight will be too forward. I want my drill just the right height to get my heart over the drill. Okay, that centers my body weight. And now the reason we want a skinnier drill is because of friction. Now, people mistakenly will think that a fatter drill provides more friction, except for that friction's all spread out. What counts is single point friction. And now a smaller drill is going to spin more times over the same length of rope, okay, with the bow and drill. Now, if it spins more times, it means that there's going to be more friction on any single point, which means there's going to be more heat on any single point, which means it's easier to ignite. So we're going to demonstrate that principle here now. So what I'm going to do is I'm going to mark my bow drill here, and here. And now I'm going to make a mark that you can easily see on each drill. I'm going to start each drill at one end and go down the other end so you could see that the skinnier drill spins more times. Okay, so there's our mark on the string. There's our mark on the drill. Watch. Okay, now we've hit our other mark. See, there's our mark on the string. There's our mark on the drill. See the size difference? Okay, there's our string mark. Okay, there's our drill mark. Can you see that? Okay, now I'm gonna turn. Oh. Okay, and there's our marks. There's our string mark. There's our stick mark. So you can see that this spins around more times over the same length of string. More RPMs means more friction on a single point. More friction on a single point means more heat. More heat means a better chance of making fire. That's why we get the thinnest drill possible without breaking. That's why I choose a drill about the width of my forefinger. Now when it comes to the dimensions on this baseboard, this must also be very exact. Okay, now when it comes to harder woods, like this plank of just willow, it should be 1/2 inch to 1/4 inch thick, okay? 1/2 inch to 1/4 inch thick. When it comes to softer stuff like this chunk of cottonwood bark, or this palm stem, okay, it could be one inch to 1/2 inch thick, okay? And it should be long enough for you to put your foot on and fit one of these pilot holes and fire-bearing notches. Now, the reason for the thickness of the baseboard is because that dust is not going to ignite until it has contact with the red-hot spinning drill. Okay, so you don't want to have to drill through too much board before you hit the dust that's filling up at the bottom. That means less drilling and fire quicker. And this can be quite physically strenuous, so you want to minimize your drilling time. And when your life is on the line, you want fire fast, right? Now you're going to want this wood to be much softer than the drill. Now see, I can easily make a mark with my thumbnail on these boards. Okay, it doesn't matter what species of wood this is, it matters the material properties. I can easily leave a thumbnail, yet when I knock on it, it still sounds like a door. If you knock on a piece of cork, it's not going to make that sound. Now I want to make sure it's clean of big cracks. Okay, it's clear of big knots or pin knots in there where you're going to be bowing, and make sure it's not going to crumble apart when you step on it, okay? Now those are the properties of the wood you're going to select for your baseboard. There are some species that seem to be better than others, and we're going to get into that. But you can't always know what the trees are around you, okay? Perhaps you're an international traveler. You can't be expected to know every species of wood. Now you don't have to know what wood works because you know why it works. Once your baseboard is prepared to its appropriate thickness, the first thing we're going to do is start on your pilot hole. You need a pilot hole before you start. That's this hole here, because you're pushing and pulling on the drill. It'll fly out. Now your pilot hole, the tip of your pilot hole should be 1/4 to 1/2 inch from the edge of your baseboard here. You see this distance from the tip of your pilot hole, see, from your tip of your pilot hole to the edge of the board there, where it exits the board, should be 1/4 to 1/2 inch, okay? So I'm going to mark where the tip of the pilot hole is. Now I'm going to mark around my drill, because my drill has to fit really snugly in this pilot hole. It can't dance around in there. It has to concentrate the friction on a single point. That's why it has to fit in there just right. So now that I have it measured, I can go ahead and dig it out. Now when I dig out my pilot hole, I want to be sure that it forms a cylinder and not a cone. And what I mean by that is I want the walls of my pilot hole straight so that it forms a stop for the drill, so that the drill can't pop out of the pilot hole as easy. So once you believe your pilot hole is about snug, what we're going to do is burn it out, because this is going to expand a little bit once I really drill into it, and our notch has to be in exact proportions to the pilot hole. So now I'm just going to burn it out. So I want to go ahead and zoom out there. So all I'm going to do now is just give it a few turns to really form out the pilot hole and see where it's at. Okay. Go ahead, zoom in there. And now for the notch. The dimensions of this notch are critical. If they're not just right, you have a good chance of just getting smoke and smoke and smoke and no ember. Okay, now how to measure this. We want our notch where it exits the board, here, to be about as wide as the pilot hole. That's why I'm making these lines. Okay. Now where this notch is going to enter the pilot hole, I want it approximately half as wide as the pilot hole. Okay. Now I'm going to undershoot this at first and undercarve it so that I can just fine tune it after I get it started. Now to make our V, we're going to connect these corner to corner. Now these lines can serve as a guide for giving you more exact dimensions on your notch. See our V here? Okay, now I'm going to go ahead and carve this out.